do here is we have to set aside our familiarity with the integers, and we have to look at them as just this object. We have to say this is this object. We're going to accept these axioms. Everything else we want to figure out has to flow from these axioms, and that's the trade-off we make. And on it are the important facts. I'm not going to rewrite them on the board because that would be a big waste of chalk and time. But I will highlight some of them for you to just accept some things. So we're just going to assume that there are these numbers, that if you can get from 0 to 1, you can get from 1 to 2, and you can get from 2 to 3, and then you can go backwards from -1, -2, -3, etc. And we're not going to get into what addition means. We're just going to assume that addition exists and that we know how to calculate it. And we're just going to assume that multiplication of integers exists and that we know how to calculate them. And there are some properties that we have here that are like even more basic. So for one thing is, we've talked about this before, but if you add two integers, you get an integer. And that's something we're just going to give you. There's really not a good way to get at it other than just a fact that we accept. So that's something you're allowed to just accept on faith. Another thing is, for any integer, it's either positive, negative, or 0, and it's exactly one of those things. The thing's probably not controversial. Now, one of the things that's worth highlighting here is these are our properties that we have discussed before. We've talked about binary operations that you can define on different sets, and we've talked about where it's associative. You can do the calculation, you can group the calculation. Addition is associative and commutative, and on previous assignments and discussions, you talked about what it would be like if you had binary operations that were, for instance, associative but not commutative, or commutative but not associative. And this is to like say, well, this is really familiar, but there are places where this doesn't happen. Now, this is a property that we haven't talked about, which is called having an identity element. So having an identity element is a property of the set with respect to an operation. Basically, it's an element in the set that if you do the operation for that special identity element with any other element, you get back the other element. So if you're looking at like just an arbitrary binary operation, which I'll call ampersand, then the identity element would be x ampersand identity equals x. In other words, it doesn't change. And identity ampersand x equals x. That's something you can talk about for any set that has a binary operation, is does it have an identity element? And the other thing is, if you have an identity element, then you can talk about inverses. So I don't like saying negative here. I prefer to say the opposite. Because negative is less than 0. This isn't necessarily a negative number, but it's the opposite additively of whatever I'm adding. So every element has something that you can add to it to get back to 0, right? And we are assuming, we are giving you that these things are true about addition on the integers. Any questions, thoughts, or comments on anything you said so far? Like how well it is ranked? Let's let P be the set of integers that are strictly greater than 0. The positive integers. So let's look at the set of integers that are strictly greater than 0. Sitting green on green. Define binary operation. Can you define addition on P? Just take the ordinary sum of x plus y. And the question is it, if you add two positive integers, do you get a positive? So this is a perfectly valid binary operation. And it's associative and commutative. It inherits that. Does it have an identity element? No. What would the identity element be? You're looking for a positive integer that if you add it to any other positive integers. Right. So the set is part of the operation. So on the integers, addition on the integers has an identity element. Addition on the positive integers doesn't. Inverses on the positive integers. Now let's look at multiplication on the positive integers. So is this actually a binary operation? It's a valid binary operation because when you combine two things in the set, you get something in the set. Does it have an identity element? Yes. Is there anything you can multiply positive integer by that will give you back the original number? Yes. So the identity element here is 1 for this operation on this set. In general, do elements have inverses? Because if you wanted to multiply 2 by something that would give you back 1, you would need to multiply by 1/2, and 1/2 is not in your set. So once you have your identity element, When you're looking for inverse elements, the question is, can you operate with something that you subtract? And it doesn't make sense unless you have an identity, right? So it only makes sense to talk about having inverses if you have an identity element. Yes, it's possible some elements will have inverses and some will not. In general, if you say that an operation has inverses, you're saying that every element has. Because there is one element here that has an inverse. One. One is its own inverse because one time. But in general, inverse elements don't exist for most elements. So I'd like for you to look at these 4 properties. I'm going to give you 2 binary operations to investigate. Do you feel up to it?